sketch f of x is equal to 2 to the x, then sketch f of x is equal to 2 to the negative x, f of x is equal to 2 to the x plus 3, and f of x is equal to the opposite of 2 raised to the power x minus 4. So the first thing that I'll do is focus on the first function, f of x is equal to 2 to the x, and I'll sketch that in blue in the first grid. Alright, so what I'll do here is create a small table of values, so x versus f of x equals 2 to the x, and just use a few values for x, negative 2, negative 1, 0, 1, and 2. Alright, now I'll start with 0. 2 to the 0 is 1. 2 to the first, if x is 1, 2 to the first is 2, and if x is 2, 2 to the second is 4. For negative 1, 2 to the negative first is 1/2, and 2 to the negative second is 1/4. So I'll plot those points, and let me just use a scale of 1 on each axis. So then let's see, I'd have the point negative 2, 1/4, negative 1, 1/2, 0, 1, 1, 2, and 2, 4. The next point would be 3, 8, if we wanted to. And so what we remember is we have a horizontal asymptote as x approaches negative infinity, so the curve slowly increases and continues to increase through the points upward. So there's the basic function, f of x is equal to 2 to the x. Alright, now, f of x is equal to 2 raised to the negative x. So I'll sketch that here. Now there's a couple of ways of looking at this. One thing that you might have learned from your basic transformations is that if you replace the x with a negative x, that is a flip about the y-axis. And so what that does is takes that whole curve that we just drew and rotates it about the x-axis. And so we would have the points, let's see, we'd have negative 2, 4, negative 1, 2, 0, 1, 1, 1/2, and 2, 1/4. Another approach is to remember that if we have 2 to the negative x, that's the same as 2 to the negative first to the x, which is the same as 1/2 to the x. And then you could create a table of values for that function. In either case, we get a decreasing function that is asymptotic to the x-axis as x approaches positive infinity. If f of x is equal to 2 to the x plus 3, that is a shift of the basic function. That's a shift up 3 units. And so what we would do is we would take our horizontal asymptote at y equals 0 and move it up to y equals 3. And then we could just plot all of those other points, raising them up 3 units. So I'd have negative 2, 3 and 1/4. Negative 1, 3 and 1/2. 0, 4, 1, 5, and 2, 7. So I'll just kind of plot that about here. And finally, if we had f of x is equal to the opposite of 2 to the x minus 4. The x minus 4, if we replace x with an x minus 4, that is a shift right 4. And the negative on the outside is a flip over the x-axis. So if we shift everything to the right 4, let's see, we would have 2, 1/4, 3, 1/2, 4, 1, 5, 2, and 6, 4. So we would have those points, but wait a second. We also need to flip over the x-axis. So then we would have 2, negative 1/4, 3, negative 1/2, 4, negative 1, 5, negative 2, and 6, negative 4. And so then our final curve would do something like this. We would still have the asymptotic feature and a descending or decreasing function.